All right, ladies and gentlemen, hello there. We're going to talk about entropy. And we need to figure out what is entropy, and we've got to do some definitions today. And we'll work with this. And so when we talk about entropy, we're going to first look at spontaneous reactions, which is a reaction that occurs without outside intervention. So we want to know what causes a spontaneous reaction. So when we have a spontaneous reaction, something has to occur to make it go. And by our definition of spontaneous reaction, what we think about it, if a reaction causes an increase in the randomness of the universe. And everybody's like, oh, what do you mean by that? Well, it means that things become a bit more hectic, a bit more what we call entropy. And it basically is more disordered. And disorder is not a proper way to describe this. It's hard to explain, but we'll take a look at it this way. Entropy is a function, basically measurement of disorder. It's basically a bunch of probability sets. And basically a simple explanation is that a system has a lot of numbers of microstates. The more microstates it can attain and the probability of attaining these microstates, guess what? Has more disorder. Limit the amount of microstates we have, we lower the entropy. And this is what we mean by disorder, by entropy. So when we look at this, we'll take a look at, so if we have one atom and we have two possible states, we have a gas molecule and gas atom in here, could be either here or here, so there's two possible states. If we have two molecules in a container, and basically we can have both of them here, one in each, or one in the other. And this is probably 1/4, 1/4, or 1/2. And so this is what we mean by probability and microstates. We've got 3 microstates here. It could be 4 if these were actually different atoms. But if they're the same, we just have 3 microstates. So this is where we can add more entropy. If we actually have A and B, and they have 2 containers, which one can it be? A can be in this one or this one, and B will stay the same, or B will move over to here, and A can stay the same, or both can move. And this way we have 4 microstates, which has a lot more entropy than this does. So this has more entropy to it, more randomness. And so this is what we mean by entropy: how many microstates and the probability of getting to those microstates. And and depending on what we have, the more stuff you have, the more microstates. So now we're going to come to the second law of thermodynamics. And for a spontaneous process, the overall entropy of the universe increases. So that means our whole universe is going towards disorder, chemically speaking. So this change of entropy of the universe is equal to the change of the system plus the change of the surroundings. Now, when we have the delta S for the universe is greater than 0, the reaction is spontaneous. If the entropy of the universe decreases, we say it's non-spontaneous or spontaneous in the other direction. By the way, for this to occur, you need energy. So it takes energy to put things in order. And that's what everybody says about their bedrooms. So anyway, you'll get it in a minute. So now we have, if the entropy is, change in entropy of the universe is 0, it means the system's at equilibrium. There is no change whatsoever. So what affects entropy? Temperature. temperature affects entropy. And the reason why is entropy is measured in energy per temperature. So it's usually joules per Kelvin or kilojoules per Kelvin. But we're talking about joules per Kelvin. And it depends on heat flow and temperature. So the temperature actually affects the heat flow. The heat flow is actually going to designate the sign of entropy, and the temperature is the magnitude. So what do we mean by that? So the exothermic reaction, so we're talking the change of entropy in the surroundings is positive because it's actually gaining energy from the system. And an endothermic is giving energy to the system, so its entropy is negative. And for this to occur, remember that the change in entropy in the universe is positive. And so now we have this change of entropy is equal to minus enthalpy, another E word, which is going to drive everybody nuts, divided by temperature. So this is our change of energy surroundings. Now, we know this processes that increases entropy. We don't need to measure it because we know it. So if we have a reaction that makes gases, or have more gas molecules in the product, that means we increase in our entropy, because a solid is more ordered than a liquid, which is more ordered than a gas. So a solid has a lot of order to it. Liquid has more disorder. And what we mean by that is there's more microstates that a liquid could have compared to a solid. And then gas is random. The gas molecules are running around all over the place, and this is what we mean it has a lot of entropy. So this is a quick guide to entropy, and we'll continue this on Wednesday. Have a good day, folks.